Let's take some notes on calipers. Calipers are a super helpful tool for an engineer. It allows us to take measurements down to 1/1000th of an inch in a few different ways, so let's talk about this tool and how to use it. Make an entry in your notebook called Caliper Notes, include today's date. When we get started, let's first talk about the anatomy. There's a thing called a thumb wheel, and this is what moves around our carriage. So you'll notice the needle is whizzing around as I'm moving this. What we're going to see, there it is there's behind the carriage, there's a rack of little gears, and inside this dial, there's going to be another gear in the back that's connected to the needle. And every time this needle whizzes around once, it represents 1/10 of an inch. Really like dial calipers because it allows us to really see how big things are as we see that needle whizzing around. When you're using your calipers, be sure to always use the thumb wheel. It will pull back if you move it like this, but you're being really tough and kind of abusive to the gears on the inside. So the thumb wheel is a good way to have your calipers stay precise and accurate. The measurements the caliper can take come from the blades and gauges. Sometimes they're called blades, sometimes they're called gauges. Note that even though they're called blades, there is no sharp edge on any of these. The outer diameter gauges, for example, are designed for a couple purposes. It's got this thin area mainly used for applications such as getting inside things like the threads of this screw to measure the screw shaft diameter. And then we have fat parts which are designed to catch the outside diameter so we can get our thread diameter of the screw. On the other side, we have simultaneously an inner diameter measurement being taken. So for applications like trying to figure out how big a washer is, these are great to get inside. You open it up until it stops, and then you've got an inner diameter measurement. The third and final measurement that again is happening simultaneously is a depth probe or a depth gauge or a depth blade. You'll notice as I'm rolling the carriage back and forth, this is extending and retracting. Typically it's going to be for an application like we're measuring how deep something is inside, and there I could measure that depth. So now that we know the different measurements we can take, let's talk about how we actually get our measurements. In order to do so, we have to first off calibrate our calipers. So the way to do this is to open and close it a few times and just ensure that the needle does in fact stop at 0. Sometimes if your caliper is dropped or somehow jarred, the carriage can skip a tooth on one of these gears, and then when you bring it back, it will actually rest 5 or 10 notches to the left or to the right. If that happens, your caliper is not broken, it's just out of calibration. The way to adjust that is to open up the dial lock and then adjust the physical dial so that the 0 goes to wherever the needle stops. So for example, now it's out of calibration. I'll bring it back so that it is then back to 0. I'm going to then open and close it a few times and make sure that it is in fact back at 0, and then lock the dial again. Now that we're calibrated, let's look at this other dial. We talked about the dial lock. This is what's called a measurement lock. If you're ever taking a measurement in like a hard to reach place behind something, you can get it to the correct measurement, roll it down, and then lock your measurement, and then you can bring it out to where you can see it and then take your measurement. So a helpful tool. Just be sure that it's unlocked when you're using it in typical operation. Let's talk about taking measurements. The first thing to note is our dial. The dial is going to count how many thousandths of an inch there are. There's also a scale. This is going to count how many tenths and whole inches we have in our measurement. So I always like to start by drawing out my placeholders for all of these different measurements. And then I have the scale and the dial. The scale is always going to fill in the first two numbers. So for example, I can slide this and let's lock it down to a random location here. I have 0 full inches and I have 5/10ths of an inch. So in our notes, we could go ahead and say that that is 0.5. So the first two numbers came from the scale. The next two numbers come from the dial, and this is how many thousandths of inches that we've got. So we have, there's 10, 20, 30, 3 thousandths of an inch, or we have 3/10ths of an inch plus 3 thousandths. So there's my 3/10ths and my 3 thousandths. An easy way to think of it is the first two come from the scale, the next two come from the dial. So let's go do another practice one. I'll arbitrarily put this, we'll say, let's get some whole inches in here. This one looks pretty good. And let's do this. So I have 0, there's 1 full inch, and I always wondered, does the 4 count or does the not 4 count? The thing to remember is that as the needle passes towards that 0, it is approaching that 4 dash. So now we know that it actually is still within the 3. So the first 2 numbers are 1 and 3. Let's jot that down. 1 and 3. The next 2 numbers come from the dial, and we've got an 83. Notice it's kind of in between. It's closer to the 83, so we'll write down an 83. So our final measurement of those is 1.383 inches. Now that you know how it works, let's do some checking for understanding. To do so, we are going to use the DC motor that is common in many projects. We'll start by doing the maximum motor width. Let's take a look at this. And in your notes, go ahead and write down what you feel this measurement is, and I'll go along with you. Okay, let's move on to the minimum motor width. We're going to go to the maximum motor length. And now let's use the depth probe to measure the motor shaft length. We'll go to this one. Okay. That's an interesting one. You see how the needle's perfectly between? I feel it's okay to write down a 10,000th. Well, we'll see. We'll take a look at it. Here's my answers. See how yours compare. Okay, throw some units on here, and if we agree, you're ready to go with your calipers, and you're an engineer that can design down to the 1,000th of an inch. Great job.